Have you ever wondered how quantum computers came into existence? Was it the invention of one scientist, or was it the result of more than a century of brilliant discoveries? Welcome back to TechVerse by Niharika. In today's video, we'll travel through time and meet the extraordinary scientists whose idea transformed physics and gave birth to quantum computing. Let's begin our journey. As we are going through the history of quantum computing, let's start with Max Planck. So let's imagine there is an old Germany, glowing iron rod, fire turning from red to white, where Max Planck writing equations. The year is 1900. Scientists are confused. A heated iron rod changes color as it gets hotter, from red to orange, yellow, and finally white. Physics at that time couldn't explain why. One scientist dared to think differently. His name was Max Planck. Instead of believing energy flowed continuously, he made a revolutionary assumption: energy is released only in tiny packets. He called these packets as quanta. Ironically, Planck himself believed this was only a mathematical trick, but history proved otherwise. Without realizing it, he had just given birth to quantum theory. So Planck is what suggested energy is in the form of packets. Moving on with Albert Einstein, who is the light detective. So let us imagine sunlight hitting metal, electrons flying out, and Einstein thinking. Scientists knew light behaved like a wave, but something strange happened during experiments. When light hit certain metals, electrons jumped out immediately. Nobody understood why. In 1905, Albert Einstein proposed something astonishing. What if light is made of tiny particles? He called them photons. This perfectly explained the mysterious photoelectric effect. Interestingly, Einstein won the Nobel Prize not for relativity but for this discovery. Scientists had another puzzle. If electrons circle the nucleus, why don't they simply fall inside? In 1913, Niels proposed that electrons can exist only in specific allowed orbits. They can jump between these energy levels but never stay in between. This explained why atoms are stable. Scientists wanted to know everything about an electron, its exact position, its exact speed, but Werner proved something shocking. Nature doesn't allow it. The more accurately you knew one, the less accurately you know the other. This becomes the famous uncertainty principle. Quantum physics had become stranger than anyone imagined. Uncertainty principle is what given by Heisenberg, Werner Heisenberg. Another scientist had a different idea. What if particles don't behave like tiny balls? What if they behave like waves? Erwin developed an equation that predicts how quantum particles evolve over time. To illustrate the weirdness of quantum mechanics, he imagined the famous Schrodinger's cat, a cat that is simultaneously alive and dead until someone opens the box. Not a real experiment, but one of the most famous thoughts experiment in science. Fast forward to 1980s, scientists wanted computers to simulate atoms and molecules, but classical computers struggled. Richard Feynman asked a simple question: if nature itself is quantum, why not build a quantum computer? The single idea launched an entirely new field: quantum computing, the father of quantum computers. Feynman had the idea, David took it further. He designed the concept of universal quantum computer. Just as classical computers can run any program, David imagined a quantum computer capable of performing any quantum computation. He became one of the founders of quantum computation theory. For decades, internet security relied on one assumption: factoring huge numbers is extremely difficult. Then Peter changed everything. In 94, he developed an algorithm that allows a quantum computer to factor large numbers dramatically faster than known classical methods. Suddenly, people realized quantum computers weren't just scientific curiosities, they could transform cybersecurity. So that is where Shor algorithm existed, which broke the encryption. Breaking of encryption by Shor algorithm, which is a threat to classical encryption. Imagine searching for one book in a library containing millions of books. A classical computer checks them one by one. Grover developed an algorithm that can find the correct item much faster than classical search. It became another landmark achievement in quantum computing. So as Shor developed algorithm for encrypting breaking of encryption, whereas Grover's approach or Grover's algorithm is what we'll come across faster database search. One scientist inspired another. Planck introduced quanta. Einstein showed light behaves as particles. Bohr explained electron energy levels. Heisenberg introduced uncertainty. Schrödinger described particles with wave equations. Feynman imagined quantum computers. David designed the universal model. Shor revealed the power of quantum algorithms. Grover demonstrated faster searching, and together they built the foundation of today's quantum revolution. Quantum computer is no longer just a theory. Today, companies like IBM, Google, Microsoft are racing to build practical quantum computers that could transform medicine, finance, artificial intelligence, cybersecurity, and many other fields. If you enjoyed this journey through the history of quantum computing, don't forget to like the video, subscribe to the channel, and share it with friends who love science and technology. Thank you for watching. I'll see you in the next video.